Welcome! In this explainer, we're going to cover a really powerful technique that'll help you sharpen your skills and, more importantly, boost your speed for your physics exams.
So let's start with a feeling I think we all know, that pressure. You're staring at a tough physics problem, you can practically hear the clock ticking down, and you know every single second counts. It really is a race against time just as much as it's a test of your knowledge.
But what if you had like a secret weapon, a kind of shortcut that lets you just slice through problems, check your answers, and confidently cross out the wrong options, all without getting bogged down in those slow, careful calculations? Well, that's exactly what we're going to dive into.
Today, we're going to unlock two key skills that honestly act like a superpower in the exam hall: the art of approximation and the simple logic of dimensional analysis.
Think about it like this. On one side, you've got the slow, traditional path, writing out every single step, using exact numbers, and double-checking every little detail. Sure, it's precise, but wow, is it a time drain? But on the other side, you've got the smart path. This is all about using quick estimation and logical checks to get to the right answer. Or, at the very least, eliminate the wrong ones in a fraction of the time. This isn't just about being fast, it's about learning to think like a physicist.
First up, let's master the art of the good enough answer. Because let's be real, in a multiple choice exam, good enough to spot the correct option is often all you really need.
The first tool in our little approximation kit is understanding the order of magnitude. This isn't about getting the exact number. It's about quickly figuring out if your answer should be in the tens or hundreds or thousands. It's a super quick sanity check to see if you're even in the right ballpark.
And this is where it gets really practical. Look at these constants. Using g as 9.8 can be a pain to calculate with, but for a quick estimate, rounding it to 10 makes mental math incredibly fast. The same goes for these other common constants. Honestly, just knowing these simple approximations is a hack that pays off big time when you're under pressure.
So here's the process boiled down into 4 simple steps. First, just identify the most important numbers in the problem. Second, round those numbers to easy-to-use values like the ones we just saw. Third, plug them into a simplified version of the formula. And finally, and this is the most important step, look at your answer and just ask yourself, does this actually make sense in the real world?
Okay, let's move on to our second tool, which is my personal favorite. I want you to think of it as a grammar check for your physics equations. It can instantly tell you if something is fundamentally wrong.
This is called the principle of homogeneity, and it is a non-negotiable rule in physics. Every single term in a valid equation has to have the exact same dimensions. You can't add apples to oranges, and you definitely can't add a unit of length to a unit of mass. The universe just doesn't work that way.
And this quote just brilliantly illustrates the power of this idea. If you check an equation and the dimensions don't match up, it is guaranteed to be incorrect. No exceptions. In an MCQ exam, that's an incredible advantage for spotting and throwing out flawed options right away.
All right, enough with the theory. Let's see how this actually works with a quick, practical example.
So when you see this, your first instinct might be to grab a calculator and plug in 9.8 for g. But let's just resist that urge for a second and try to estimate it instead. So here's the crucial part. We use our simple formula for freefall and we plug in our rounded value for g, which is 10. The math suddenly becomes super easy. 2 times 100 is 200, divide that by 10 and you get 20. Now we all know the square root of 16 is 4 and the square root of 25 is 5, so the answer has to be somewhere between 4 and 5 seconds. Just like that, you've massively narrowed down the possibilities.
Now let's bring it all together and apply this way of thinking to a real NEET-style multiple-choice question and see just how much time we can save.
Okay, here's a pretty typical question. On the basis of dimensions, which of the following relations for displacement, y, is not correct? Now don't even think about solving it yet, just look at the structure of the options.
Our first step, always, is to run a quick dimensional check. And here's the key piece of information you need to remember. The argument of any trigonometric function, like sine or cosine, has to be dimensionless. It can't have units like meters or seconds inside those parentheses.
So let's look at option B. It's sine vt. Velocity v has dimensions of length over time, and t is time. So vt has dimensions of length. That's not dimensionless, so option B has to be wrong. Now for option C, sine t over a. Here t is time, and a is amplitude, which is a length. So the dimensions inside are time over length. Again, not dimensionless. So option C is also dimensionally incorrect.
And just like that, with zero complex physics, we've eliminated 2 of the 4 options. We've gone from a 25% chance of guessing right to a 50% chance in about 10 seconds. This isn't just guesswork, this is using logic to work at high speed.
Of course, as powerful as this technique is, it's not a magic wand. It's a specific tool for a specific job, and it's really important to know when not to use it. Look, estimation is for knocking out obviously wrong answers, and for checking if your result is plausible. It's not for finding the final answer when the options are really close to each other, like, say, 4.52 seconds versus 4.58 seconds. For that, you need precision. Also, while dimensional analysis is amazing, it's blind to dimensionless constants. It can't tell you if a formula needs a pi or a factor of 1/2. So it checks the formula's structure, but not every single numerical detail. So the real takeaway here is to shift your entire mindset. Stop seeing physics problems as just a long series of calculations you have to get through. Start seeing them as puzzles, where logic, intuition, and these quick checks are your primary tools. Use them to work smarter, not just harder.
And that's the end of our explainer. I'll leave you with this thought to take with you. Next time you face a problem, just take a breath before you start calculating. Ask yourself, can I estimate this? Can I check the dimensions? You might be surprised at how quickly the answer just reveals itself. Good luck.